Hello guys, today I'm going to review pre-release task 2 with you. I'll assume that you guys have read the scenario for the pre-release task, so I'll straight get on to the code, explanation of code, and what kind of data structures, validations are used in the code, and what kind of input types are available for this given code. So starting with the code, I first initialize a variable called total price. And this variable total price will store the amount of money that the user will have to pay when he or she books a journey. So then create a while loop, and this while true loop is created so if the number of tickets entered by user is not available or in invalid format, the code will continuously ask user to enter the correct or valid number of tickets that are available. So to explain in detail in this while loop, there are two separate while loop for inputting correct departure and return time. So starting with inputting departure time, first this code inputs the time for departure, which is available between 9, 11, 13, and 15. And that input is stored as an integer value in a variable called departure time. So this while loop is a validation for entering correct time. So if the user enters 8, for example, for departure time which is not available, it will be smaller than 9, so the while loop will ask user to enter the correct time again until the correct time is in 9 or 11 or 13 or 15. So for example, if it's bigger than 15, for example 16, it will be greater than 15, so the while loop will ask the user again. And if it's an even number, the modulus 2 of even number is always 0, so 0 is not equal to 1, so the while loop will ask the user to enter correct time. So if the user until the user enters correct time, this validation will catch user. And after that loop, you store the time user inputted will be found out in the departure available times array and be stored as an index value in a variable called deep index, because you want to use that index value for finding out the number of tickets available for that specific time and to store how much money earned for that specific time. And you would do the same process for inputting return time. Just one thing that is different in return time to departure time is that there are one extra validation: read time has to be bigger than deep time. This means that return time always has to be later than departure time because the user cannot return if they had not departed yet. So in inputting return time, it'll be between 10, 12, 14, 16 that user can correctly input. And it'll store that time user chose as the index value of it in a variable called read index. And finally, it asks you to input number of tickets that the user wants to buy. And this if statement compares the number of tickets the user wants to buy in a specific time is available. So if it's not available, it'll print not enough tickets, and the loop will go again, asking user this whole process one more time. If the number of tickets the user wants to buy is available, the loop will break and then move to the next part of the code. So the next part of the code is updating number of tickets available. So once the user passes the first part of the code, it means the user has successfully purchased the number of tickets. So we have to update the number of tickets that are currently available. So using that index value stored at the previously, you find that number of tickets available for that specific time in the array, and you subtract the number of tickets that the user wants to buy, and the new available number of tickets will be original number of tickets subtracted by the number of tickets that the user wants to buy. And you would do the same for the return time. Return available number of tickets for that return time. And finally, you would add the number of tickets times journey cost, which is cost of departing and returning, to the total price. Just don't get confused. This plus equal and minus equal signs is totaling. You don't have to write total price equals total price plus num tickets times journey cost. In Python, you can just simply write this. And next, we still haven't touched the calculating discount part. So the number of tickets that the user wants to buy, if it's between 80 or 10, so if the passenger number is between 10 or 80, according to the pre-release task, you get a discount. So the amount of discount the user has to pay is calculated through this formula. So you subtract the modulus 10 of number of tickets from number of tickets. This means it's just rounding the number down to the 10th place. And you multiply that to the journey cost and multiply that by 0.1 because the discount is 10%. And it will print how much discount you would get and subtract that discount from total price, which will be the final price that the user has to pay. If the number of tickets is out of range, the total price previously calculated will be the final price the user has to pay. And finally, you have to update the price for the train trips. And you would use that departure index value again to store the revenue earned for that specific time in departure array. So the reason you add half of the total price is that the total price is the price of going up and down. And for storing individual money for going up or going down, you have to divide by 2. And then you will print the total cost. So how to explain the code? There is a question asking how did you code it for task 2 in pre-release task. So I'll go step by step. Basically, it's just reiterating what I said when I was explaining the code. So first, you initialize variable for total price, setting it to 0. Then include prompts to ask the user to input departure and return time, number of passengers, and the inputs and variables. Create a while loop for inputting correct times available tickets. Include validations, so time for departure and return must be only between 9, 11, 13, 15, and 10, 12, 14, 16. Use an if statement including modulus for distinguishing odd-even numbers. If the time is invalid, ask for re-entry. And then store index value of selected times in variables. Input and check if the number of tickets is available by comparing the number to available tickets for corresponding time in arrays found out using stored index value. So if it's available, the loop will break, and if it's not available, the loop asks time and tickets again, and appropriate messages will be shown. And then calculate row total price by multiplying number of passengers to the individual cost for the whole trip. Using if statements, check if the number of tickets are between 10 and 80, and if it's between the set range, it'll calculate the total discount using formula num tickets minus num tickets modulus 10 times journey cost times 0.1. And then subtract the discount from the total price as the final price. If it is outside the boundary, raw total price calculated previously will be the final price. And then update available tickets arrays by subtracting selected number of tickets from available tickets for a specific time using stored index values. And update money earned arrays for departure and return by adding final price paid divided by 2 to money earned for specific time using stored index values. And then we'll look at data structures. So task 2 is the longest task in the pre-release 2021. And constant, variable, and arrays are all equally used in this task. So starting with constant, a constant called journey cost is used, and the value for this journey cost will be 50. And the data type is integer, and its use will be the amount an individual has to pay when departing and returning. So for variables, 6 main variables are used in the pre-release tasks 2. So first, deep time variable is used, which is an integer variable, and this is used to for storing selected time for departure. And deep index is used, and this is also an integer variable, and it is used to store the index value for selected time for departure. And similar to deep time and deep index, read time and read index would be also used. And then num tickets, which is an integer variable used to store selected number of tickets the user wants to buy. And finally, discount, another integer variable which stores the discount the user receives. So all the variables used in task 2 will be integer variables. And finally, we'll look at arrays that are used in pre-release task 2. For arrays, the arrays used in task 1 will be used here. So deep avail times for departure times, deep avail ticks for available departure tickets for train times, and deep money in for money collected for each train departure journey. And similar to these 3 departure arrays, return arrays will have the same arrays. And then we'll look at validations. So string validation is used in task 2. First validation is a validation of entering departure time, and it is used to ensure that selected time for departure is correct. The second one is about selecting time for return train. So this is used to ensure that selected time for return is correct. And finally, deep time is smaller than read time, and this validation is used to ensure that return time is always later than the departure time. These are the 3 validations used. We'll finally look at sample data. So the question might ask suitable sample data for pre-release task 2, what kind of data it is, and what does this data do. The first type of data is called normal data, and example of this is time 11 for departure and time 14 for return, and number of tickets 200 for tickets. So this normal input would be used to see if the program accepts this data. So if you enter these examples, it'll work perfectly. The next type of data is abnormal data or erroneous data, and it is used to see if the program rejects this data. So if you enter departure time for 10, it will reject because it is an even number. And similarly, if you enter 19 for return train, 19 is bigger than 16, so it will be rejected. And finally, if you enter number of tickets 800, it'll be rejected because there are only 480 or 640 tickets in the trains. Number 3 is extreme data. Extreme data is data that is at the boundary of the available inputs. So departure time 9 and return time 16 and tickets 480 is an example of extreme data. And extreme data is used to see if the program accepts this data. So sometimes you're a bit unsure if the number at the boundary will be accepted or not, and extreme data is used to test this. And that are all for pre-release task 2 that you have to know. And I hope this video helped you, and thank you.